And of course, if you're learning about civil engineering or engineering geology, one of very famous case you must be know is in Italy. In 1963, we call Vajont. Vajont is a very popular case because during the heavy rainfall, actually the construction of the dam doesn't fail. It's quite strong. But as a whole of the sediment and the whole of the rocks just go to the dam, the water reservoirs area, and they make the tsunami in the Vajont. So in that time, the tsunami, the high is about 265 meters. So you can imagine, you have the landslide dam, the construction of the water reservoir is quite stronger, but the problem is the whole material just falling down in the water reservoirs area, and they met about 2,500 people was died because that. So Vajont is one of very popular case. I think the whole engineering geologists must be know and learn what's happened in Vajont. So that is, you see, in 1969, actually the first journal we call Rock Mechanics and Engineering Geology was in 1963. But after 1969, they just changed from the Rock Mechanics. So I think the geology students must be know very well about that. It's good because that is quite important moment. And also they have some of international journal of rock mechanics and the mining science, and also mechanical. So that is also in 1964 engineering geology. That is the top one, the journal for the civil engineering, and also the first one, the engineering geology conference was in Lisbon, and also, however, in 1966 in the British, they also have in the mining area, they have the big landslide. It was also made a lot of the damage in that time. So they have more than 100 people was died, and also they have some of the study case in this area. So that's why just couple years later, 2 years later, they have 25 the Journal of Engineering Geology was in that time. Okay, but however, the list just want to told you all of evolution about engineering geology actually is they have a very strong link with what we do during the evolution. And for example, in the South Africa, you can imagine they have a lot of mining, right? So they also make some geological classifies we call the RMR. And in Norway, actually they have a Q model. It's try to understand, try to separate the rocks mechanically. But in Taiwan, actually we have made the road. It's quite later. I mean, it's in 1976. We just stopped our the work to understand how can we manage the slopes area. So in 1981, so that is first time we make the channel, we call 新奥功法. That is, how can we make the channel by the Altish. The Altish is because you can imagine Altish, they have a lot of mountains just like Taiwan. And so they make a lot of channel. So they just make the new method we call the 新奥功法. And in 1982, the reservoir we call Fei actually just very near the Xueshan Range. And we try to use the different methodology. And the first journal for the Taiwanese and the writing in Mandarin, we call the 地宫技术. That is in 1983. And after that, they have so many different civil engineering construction over that time. And from 20th century, actually they have a lot of the geological hazard was happening in Taiwan. Like in Hualien, they have so many debris flow. And also in the between Taipei and the Yilan, we make the tunnel we call Xueshan, the Pinling tunnel. And also in Nantou, 1996, the Shenmuchun debris flow. That is a very serious typhoon, we call it Hebo. And after Hebo, actually the study about the debris flow in Taiwan is quite explored in that time. And not too far away from our university, and in 1997, there was the construction, the building we call Lincoln Dashi. He was constructed at the deep slopes area we call Xi. And just after typhoon, and in Xizi they have so many the flooding, but in that time they also have the big city landslide. But however, you can see that before the 1999, we call Chichi earthquake. Actually, they already have a lot of flooding, debris flow, deep city landslides, and also some of the rockfall damage in Taiwan. So if we compare whole of nature disaster, you will know Earth's process is quite important. And of course, what's happened, we can find some significance before the disaster. And of course, we want to try to stop, or we don't want to make the disaster again in the same place. We must understand what is the geological background in Taiwan, and what is the purpose for the different climate change, and especially the external event like typhoon, like earthquake. Especially after that, the slope damage, the debris flow damage actually is it's increased very quickly. And also you can imagine actually Taiwan is quite small. The most I would like to say 18% people was living in east part of Taiwan, but they still have the 20% who was living in the mountainside. And how we just developed too fast, and the people who were living in the mountainous area actually is it's become very difficult for the geological disaster. But however, you will understand Taiwan is quite new. Earthquake, landslide actually is the basic we will happen every year. So that's why we must be understand the geological process, and we also must be to understand civil engineering construction. Okay, so usually when we want to talking about the relationship about the geology process and the geological hazard, we will separate different topics. So just like nature hazard, what is mean nature hazard, and the river and the flooding, of course the landslide with the of the phenomena, and of course the earthquake will relate with different phenomena, and the volcanoes activity maybe not too much in Taiwan, but especially like Philippines, Indonesia, and even in Iceland, they have some problem about the volcano activity. And of course, Taiwan is an island, so we have some coastal hazard actually around the coast. So that is also we call that the geological perspective. Okay, so we're just talking about what is engineering geology, right? And what is geological engineering. But also, I would like to move to geotechnique engineering. Geotechnique engineering, actually, if you still remember, I'm talking about one journal, the first journal in 1987, we call 地工技术, geotech. Actually, it's for that. So